Okay, so today we're going to look at lesson 4-2. And it's going to be our introduction to graphing quadratics. So there's actually quite a bit to graphing quadratics. So we're just going to go ahead and start with some of the basics. So the solutions to a quadratic equation are the points at which the function intersects the x-axis.
Plus, you can't get her to do nothing at home.
The solutions are also referred to as roots, zeros, or x-intercepts. So essentially the solution to a parabola, and so this quadratic, the general form for a quadratic, the general equation, if you recall, is y equals ax squared plus bx plus c, and this graphs as what's called a parabola. So a parabola is a curve that opens up or down, and so we have three different solutions, because the parabola can cross the x-axis twice, once, or no times. And so let's look at some examples of what that looks like. So two solutions might look like this. And so your roots or your zeros would be right here. So if your parabola opens up and the vertex is below the x-axis, you're going to have two solutions. Your parabola could also open down as long as your vertex is above the x-axis. One solution means that the parabola is only touching the x-axis once. So that's going to happen if your vertex is physically sitting on the x-axis. Those are arrows, they're terrible, but you got the idea. Or this way. So this would be where the vertex is, and this would be where the vertex is. And this is typically called a double root, meaning that the value that you get for x, so let's say that if this solution is 2, you're going to get x equals 2 twice when you solve. And I'm going to show you how to solve it algebraically one of these days. But that just means that you get two answers out of the same. Here you're going to get two different answers when you solve for x. No real solutions means that the parabola does not cross the x-axis at all. So it might look like this. Those are arrows. Or it might look like this. So let's go ahead and I'm not going to do all of these. I'm just going to graph a few of these today. It would take forever if I graphed all of them for you. Some of them I might talk through a few things. But there's a lot to graphing a parabola. So, again, remember that it is in the form of y equals ax squared plus bx plus c. So the first thing that we need to know is what's a, b, and c. So in our case here, so a is your coefficient of your x squared term. So I don't see a coefficient here, so it's 1. A, b, and c should never be variables, just numbers. So the coefficient in front here is 1. So a is equal to 1. B is equal to the coefficient of the x term, which is 2. And c is your constant, which is -3. So the first thing we want to find is the vertex. So your vertex is equal to, well, the x value. So let's start with the x value of the vertex. And I don't like the way I wrote that. It's really hard to write this small without getting my palm on the iPad. Okay, so the x value of the vertex, so this is x value, v for value, or v for vertex, is the opposite of b over 2a. So we're going to start with that, x value. So x equals the opposite of b over 2a. And so as we stated earlier, b is 2, a is 1. So this gives us negative 2 over 2, which is negative 1. So then we need to find the y value of the vertex by plugging it in. So I'm going to take the original function above, and wherever there's an x, I'm going to put substitution parentheses. And then we're going to put in a negative 1 and a negative 1. And then if we run that through, I get a value of negative 1 squared is 1. 2 times negative 1 is negative 2. So 1 and negative 2 is negative 1 minus 3 is negative 4. So my vertex is negative 1, negative 4. So that's the first thing I'm going to graph. Right here. There's my vertex. Then I can get two things from my vertex. The x value of the vertex gives me my axis of symmetry. That's an of. Axis of symmetry. I'm not going to spell the whole thing out. But the axis of symmetry is a vertical line. It's really not part of the graph, but it's a vertical line that we draw through the vertex, which cuts the parabola perfectly in half. And because this is a vertical line, remember vertical lines have an equation of whatever the axis is that they go through, and then the number. So because this goes through the x-axis at negative 1, the equation of this axis of symmetry is x equals negative 1. Then the other thing we get from the vertex is the max or the min value. Well, how do we know whether this has a maximum or a minimum? Well, A can tell you that. If A is greater than 1, so let me put that over here. So let's see, I think I'm going to choose pink. So if A is greater than 1, or sorry, greater than 0, which means it's positive, it opens up. If A is less than 0, which means it's negative, it opens down. So because our A is positive, it opens up. Now if I have a parabola that opens up, the vertex is here at the bottom, and so it's a minimum. If I have a parabola that opens down, the vertex here is at the top, so that's a maximum. Vertex at the bottom, minimum, top, maximum. So in our case, our parabola is going to open up because A is positive, so from this vertex it's going to open up, creating a minimum value down here. So I'm going to erase these. Okay, so we get a minimum value of negative 4. So I'm going to circle minimum. So there's two things we get from that vertex. The axis of symmetry is the x value, and the max or min value is the y value. So then I need some points. So step 2, well, let's choose a different color. Custom color palette. Let's see, how about orange? Nope, yep, maybe. Okay, I'm going to choose orange. So step 2, I'm going to find the y-intercept. Well, the y-intercept is really simple. The y-intercept is always 0c. And the reason for that is that the y-intercept, every x value on the y-axis is 0, because it cuts through the x-axis here at 0. So if I plug 0 in here, I get 0. If I plug 0 in here, I get 0. 0 plus 0 is 0. Minus 3 is negative 3. So anytime I'm looking for the y-intercept, the x values are zeros, so these are going to go away. And the constant is what's left always, so that has to be our y-intercept. So our y-intercept is always 0c. So in this case, my y-intercept is going to be 0, negative 3. So I'm going to plot that right here. And then I'm going to find its reflected point. A reflected point means how far is this from the axis of symmetry? Well, this point is 1 unit away here, then its reflected point would be 1 unit on the other side. So I'm going to plot its reflected point here, and that reflected point is going to be -2, -3. So now I have 2 or 3 values total for my parabola, but none of them so far have gotten me to cross the x-axis. So then my third option that I need to do is to find, let me get a different color. How about sky blue? So third option is more points. So we're going to create an XY table to get more points. So then I need to keep getting more points until I cross the x-axis. So I need to go to the right or to the left. Well, to the left are negative values for x. So to the right, I've got the next value to the right, because I've already used up 0. So the next value to the right is 1. So I'm going to choose to plug in 1 in for x, and I'm going to find out what my y value is. So I'm going to plug 1 in here. 1 squared is 1, plus 2 times 1 is 2, so 1 plus 2 is 3, minus 3 is 0. So when I put in 1, I get 0, which is right here, and isn't that on the x-axis, which is a solution. So that's one of the things I'm looking for, and I can reflect that point. So if I look at this point, it is 2 units away from the axis of symmetry. So if I go 2 units away on the other side, that would be its reflected point. So that would be right here, and that ordered pair is -3, I don't know why it's moving, -3, 0. So these two are my solutions, and I can go ahead and connect my points with a curve, and then my solutions would be x equals -3 and +1. The other thing that we've discussed is domain and range. So remember, domain is your left-right direction. And I want to see where is the graph on the left, where is the graph on the right. So remember, this graph is infinitely going up and to the left forever, and up and to the right forever. So no matter how much I go to the left, the graph is still going to be going up and up and up. So there is no value to the left that it's going to stop. In other words, I can put the smallest negative value in for x and still get an answer for y. So this graph is eventually going to cross both directions on the x-axis. So my domain is going to equal -infinity to +infinity. Now my range, I can actually help, this max and min value can help me find my range, because my range goes from bottom to top. It goes in the direction of that y-axis. So my smallest range value, there's no graph down here. No graph, no graph, no graph until I hit this value right here. This y value is at -4. And isn't that my minimum? So for range, if I actually have a minimum value, that's going to be my smallest value in my range. So my smallest value is -4. And for right now, you're always going to put brackets around your number. And then the other value is always going to be some form of infinity, because my graph is going from -4, continually going up and up and up forever. So that's +infinity. If this had been reversed and this graph opened down and this was my maximum value, and if the graph opened down, then my minimum, because the graph would be continually going down, my minimum would be -infinity until it reached this maximum over here at -4. So if it says a maximum, it's going to go over here. Minimum is going to go over here. 100% of the time, your domain is always -infinity to infinity on these parabolas. So then let's look at the next graph. This one we're not going to graph, but I wanted to talk about it for a couple of things. Number one, let's find A, B, and C. So A is equal to -1, because the coefficient is this negative, which means -1. B is -10, and C is -25. Now I know that this graph opens down. It opens down because A is less than 1, because A is -1. And since it opens down, right, it's going to go in this direction. I don't want that. Which means my vertex would be right here. So then that means that I would have a maximum value. I'd have to find my vertex to find that maximum value. And I also can tell what my y-intercept is just from looking at the equation. So remember, your y-intercept is always 0c. Well, here's my c, -25. So my y-intercept is 0, -25. Well, that's not going to fit on this graph, clearly. So once I find my vertex, we'll probably have to use a table of values to find 2 points to the right of my vertex and then reflect those 2 points to the left, because I'm probably not going to be able to fit that y-intercept. Now hopefully I'll find my value for x that is 0 so that I can solve that equation. But let's go on and actually graph number 3. We're only going to graph 2 more. So for number 3, let's start with A, B, and C. So A is equal to 1, B is equal to -6, and C is 8. Now based upon this, I know that my graph opens up because A is greater than 0. And because it opens up, I'm going to have a minimum value. We'll figure out what that is in a minute. So then let's go ahead and find our vertex. So remember, to find the x value of the vertex, that's going to be equal to the opposite of B over 2A and B is -6 and A is 1. So I get +6 over 2, which is 3. Pardon me. So then my y value, I'm just going to plug it in. So I'm plugging that 3 in here and here. So then 3 squared, whoops, let me get my pointer going. About ready to drop my pen. All right, so then 3 squared is 9. -6 times 3 is -18. So 9 and -18 is -9, plus 8 is -1. So my vertex is equal to 3, -1. So if I plot that, that's where I'm going to be. And then immediately I'm going to put in my axis of symmetry. And then I get 2 things from my vertex. One is the axis of symmetry. So A of S, that's axis of symmetry. Remember, it's a vertical line going through the x-axis. So it's x equals, and it's going through the x-axis there at 3. Then I also can get my minimum value here, right? My minimum value is equal to -1. Now I want to find my y-intercept. So step 2, my y-intercept is 0c. So in this case it's 0, 8. So I'm going to plot that right here. And then I want to reflect it. I guess that's kind of hard to see that that's a 0, 8. Let me make that prettier. That's better. Okay, so then this point is 1, 2, 3 units away from the axis of symmetry. So if you go 1, 2, 3 to the right, we can reflect that to right there. Now the problem is, if I connect these, yes, I've crossed the x-axis, but I don't know where I've crossed the x-axis. It's somewhere around here. So typically at this point, we're going to just choose some values and put them in an XY table. So step 3 is to choose some more values. So I'm going to use an XY table. I'm just going to guess. So I need to choose some values from here to here or from here to here because that's where these points are on the x-axis. The smaller the numbers, the easier to plug in. So I'm going to start with 1 or 2. Let's go with 2. I like to plug in 1 usually, but I don't think 1's going to get us up to 0. So let's plug in 2. If I plug in 2, 2 squared is 4, or yeah, 2 squared is 4. Negative 6 times 2 is negative 12. 4 and negative 12 is negative 8. Negative 8 plus 8 is 0. So I did indeed find one of my zeros. So 2, 0 is one of my zeros. And then I'm 1, 2, 3 units away from the axis of symmetry. I'm sorry, I totally lied. Looky here, I'm only 1 unit away from the axis of symmetry. I was 3 units from the origin. So 1 unit from the axis of symmetry, so I need to go 1 unit to the right. And there we are. So those are my solutions, so I can go ahead and connect my points with a curve. So there's my parabola. These right there, those right there, those are my solutions. So my solution would be x equals negative or positive 2, and that reflected point, so the other point that was reflected, this point right here is at 4, 0. So our reflected point was 4, 0, and so that's our other solution, is 2 and 4. Now, domain and range. 100% of the time, I already told you that your domain is going to be negative infinity to positive infinity. Now, your range, because we have a minimum value, that minimum is going to start here because it goes min to max. So our minimum value is negative 1. Because that's a number, we're going to put a bracket, comma, and then so we start down here at negative 1 and we keep going up and up forever. That's positive infinity. All right, the last one that we're going to do, so let's go ahead and flip your page. I'm going to make this bigger, maybe a little smaller. Okay, so number 4 you can do. The only issue is, don't forget your A is negative, so it's going to open down, and you have this very large Y-intercept. So we're not going to graph this one. I thought that we would graph this one because it's missing the X term. This one is missing the C, but that just means that the C is 0, so your Y-intercept is here at the origin. Everything else shouldn't be a problem for you to do. And then this one here is normal as well, but it opens down because A is negative, and it does have this Y-intercept that won't fit on the graph. So let's go ahead and look at this one that's a little different since it's missing its B. And I know it's missing its B because it's missing its X term. So anytime it's missing a term, in this case it's missing X, that means that B must be 0. So A is 1 because that's the coefficient of the squared term. So A is 1. Because it's missing the X term, B is 0. And C is always the constant, in this case, negative 9. So I know that my graph opens up because a is greater than 0. And so let's rewrite that so it's prettier. What can I say? Opens up because a is greater than 0, and that's going to give us a minimum if it opens up, right? So let's find the vertex first. So the x value of the vertex is the opposite of b over 2a. All right, so b is 0 and a is 1. So the opposite of 0 is still 0. 2 times 1 is 2. 0 divided by anything is 0. So then your y value, we're going to plug that 0 in here. 0 squared is 0, minus 9 is negative 9. So your vertex is 0, negative 9, which actually ends up being your y-intercept. So let's plot that. All right, then we're going to plot our axis of symmetry, which actually happens to be the y-intercept. The equation for our axis of symmetry, AOS, axis of symmetry, is x equals 0. Our minimum value is equal to negative 9 because that's what our y value is, right? So our y value gives us that. Then normally we would do the y-intercept, but in this case our vertex is the y-intercept. So instead we're going to have to do a table of values. So we're going to find some extra points. Hopefully in the process we'll find the solution as we do this. So I'm going to choose some points to the right and then reflect them to the left. So I'm going to just start with 1 and 2 and plug those in. And so 1 squared is 1, minus 9 is negative 8. I didn't find 0 yet. We're going to plug in 2. 2 squared is 4, minus 9 is negative 5. So we didn't get to 0 yet. Let's go with 3. So 3 squared is 9, minus 9 is 0, and there it is. So let's plot those 3 points and then reflect them. So 1, negative 8 is right here. It is 1 unit away from the axis of symmetry, so 1 unit to the left is negative 1, negative 8. Then we're going to plot 2, negative 5, which is right there. 2, negative 5 is 2 units from the axis of symmetry, so go 2 to the left. And you've got negative 2, negative 5, and then 3, 0 is right here, and 3, 0 is 1, 2, 3 units away from the axis of symmetry, so 3 units to the left is here at negative 3, 0. So if I connect my points, my solutions would be x equals negative 3 and positive 3. And then my domain and range. So again, 100% of the time your domain on these graphs are negative infinity to positive infinity because the x value is unrestricted. Then my domain or my range, remember I can get my range from my max and min value. So in this case, because I have a minimum, my minimum goes here. If I had a maximum, the maximum would go here. So my minimum value is negative 9. We always use brackets. So as you look, coming from the bottom, the very first y value I encounter is right here at a y value of negative 9. And the parabola just keeps going up and up and up and up infinitely. So it stops at positive infinity. Now go ahead and try your homework. If you have any questions, just ask.